So every idea I came up with for this project really bored me. I even fell asleep. And then I had a drink and got a great idea. Painting. Sounds are mechanical vibrations that are produced in waves. Every wave is made up of different frequencies, which determine the different sounds that we hear. In order to determine these frequencies, we can visualize the wavelength and then freeze it with the help of the oscilloscope. You think you could just move a little bit faster? Uh, oh yes. Visualize and frozen, that's very clever. Now let's continue. Here we are going to simulate the oscilloscope. With the oscilloscope, we can find different things out, like the period, the amplitude, and the wavelength. With these, we can also find the frequency. The picture created is made up of two axes. The y-axis shows the intensity, which is also could be known as the power. Oh yes, muscly arm, very cool. This is the x-axis, which determines the time of the wavelength. This is how we find out the period. This is the wavelength that we simulated with the oscilloscope. The minimum of the wavelength is called the throat. Yes, throat, that's very clever, but has nothing to do with the wavelength. The maximum of the wavelength is called the crest. No, not crust. No, yeah, crest. This line simulates the rest point and is also known as zero. The distance between the rest point and the crest is known as the amplitude. The higher the amplitude, the louder the sound. Now what are you doing? You really are bored, aren't you? Everyone's voice is unique. This is because, with the exception of Mr. Tuning Fork, every sound has a different wave made up of different frequencies. Even if two people are producing the same pitch sound, they will still have a different timbre. On the sound spectrum, humans could only hear, hello, sound spectrum, thank you. Humans can only hear between 20 hertz and 20 kilohertz. We can also not produce those sounds because you cannot produce something you cannot hear. Stupid. I'm getting bored. Can we move on? Oh, light. Great. Yeah. Light also travels as a wave, and it carries energy like sound, and it also has vibrations like sound, except that with light you're dealing with electromagnetic vibrations. Another similarity is that light is made up of many different frequencies, just like sound. Light's intensity power is shown through its brightness. Without light, we would not be able to see any colors, and actually we wouldn't be able to see anything at all. We've come a long way since these torches, and with enough energies applied, we can produce light with this here. Here is a light bulb, and here is its filament. When electricity is run through the light bulb and hits the filament, it makes the atoms inside the filament go crazy and bounce around and hit into each other, which causes vibrations, which then also causes heat,
which then, guess what, causes light. In order to bring electricity to the light bulb, we need to have a light source, which is here the outlet, and connected here is the circuit, which acts as a path that carries the energy to the light bulb. This will carry the current, which is I, and will also bring voltage to the light bulb. Woo! Light! Yeah! To determine what lights we can see, we can look at the light spectrum. Visible light to us is what we call color. Anything above or below that, we cannot see. Below is infrared, which is used for things like heat goggles, which you're attempting to draw but not doing a very good job at all. That's goggles, very cute. And then ultraviolet rays are above violet. They're used in things like tanning beds, and they're also why we get burnt by the sun. Oh, that's a cute tanning bed. Nice. The longer the wavelength, the lower it is on the light spectrum. The shorter on the top. The higher the frequency on the bottom, the lower the frequency on the top. The lower the energy on the bottom and the higher on the top. Wavelength, frequency, and energy is what makes up where a light is on the scale. By looking at the similarities between light and sound, we can find ways to use them together to benefit us. Both of them create a wavelength which carries energy. Both of them are used by important organs which determine our senses. I've discovered a way that people have been teaching deaf people to determine music with just light and color. After this presentation, I will show you a video on how they do just that. They take the light and sound's different frequencies and relate them together to create different colors and patterns to determine music the way we hear it.